Everyone. Welcome to ConnectCon, presented by FGC Team 9794 Wizards.exe. Join us this week on our magical journey each day from 10 to 11 a.m. and 2 to 3 p.m. Eastern Time, where you can hear from STEM professionals from Google, APL, iRobot, and more. My name is Anika Sharma, and I will be your host for this session. Please use the chat for any questions related to the presentation, and we'll address them at the end. Today, we're honored to have Samir Durvasula speak about engineering. Mr. Durvasula is an engineer for MITRE. Thank you, Mr. Durvasula, for taking the time to present at ConnectCon.
Thank you. Do I just start? Cool. So here. Let me do this. Excellent. So, hi everyone. Today I'm going to be talking about addressing the world's health problems with engineering. It's something that I care about a lot. But first, I'm going to just briefly introduce myself and my background. So I graduated from Cornell University with a degree in electrical and computer engineering in 2017 and finished my master's in 2018. Actually, the reason that I got into electrical engineering in the first place was that in high school, I had a love for neuroscience, and particularly how all the neurons use electrical signals. And that was something that was always really fascinating to me. But at the same time, I wanted to be hands-on. I always loved using Legos and playing as a kid. So I really wanted to be an engineer. And so electrical engineering really was that fit for me. After I completed my degree, I moved on to work at the MITRE Corporation. MITRE is a nonprofit that operates several federally funded research and development centers. Basically, we do a lot of research for the government, and there's a lot of really exciting work going on. I'm also currently pursuing another master's degree in applied biomedical engineering from Hopkins. But the big thing is that I'm someone who is really passionate about engineering as a whole. I love to build and I love to design. And in particular, I'm really interested in medical technologies. And here's why. One thing that always made me really interested in the medical technology field, and something that when you talk to anyone who's working in the area, a lot of the people who work in medical devices, they'll tell you, it comes really from a desire to help patients and help doctors. I knew when I was pretty young that I didn't want to be a doctor myself, but whenever I went to a hospital, I'd see all of the different sensors and the technologies and the tools that they were using. And I knew pretty immediately that those are the things I wanted to build because they do make such a huge difference. And the reason I was interested in the building side of things was that, to me, there's just a ton of really interesting problems that exist. The body as a whole is such a well-oiled machine. We have hundred millions of neurons, each of them firing in a perfect symphony to make what we do happen. I mean, just think about the fact that we can recognize an object and look at something. That's something that even a computer takes forever to do, and really shows how awesome the body is. And that was solving problems like that was something I was really interested in. The other thing is that medical technologies as a whole is a really multidisciplinary field. When you think about biomechanics and how arms move and how our body moves, that's all mechanics. At the same time, you have biochemistry in the cells that directly lead to those mechanics. There's electronics everywhere. And so really being able to bring together all of those different fields was something that was really cool. And finally, when you put all of that together, it makes really fun problems, really fun things to think about. And as I mentioned earlier, just being able to play with things and build things, to me, was something that was really cool. And I'm sure all of you guys as robotics kids really get an understanding of that, and that's why you do what you do. But before I get into things that I've had a chance to work on, I wanted to spend some of this presentation talking about how we design and build in the medical technology field. And a lot of this probably is similar to how you guys come up and design robots and the things that you have to think about. So it's probably review. But it's also really cool and really unique sometimes to the medical field. So what I'm going to talk about today is this method called the Biodesign Method. It comes from the Biodesign Institute in Stanford. It's something that is common to all problems, but especially important to medical technologies. And it's broken into 3 different stages. One of them is identifying needs. One of them is inventing your concept or your solution. And then finally, you go towards actually implementing them and producing them. I'm only going to really talk about the first 2 because those are probably the most fun and the most interesting. So the first one is the idea of needs, and needs are really important, especially when you're dealing with health issues. It's really important to understand the problem before you develop a concept. And I'll talk a bit more about that in the later slides. And then once you select the needs, we move on to the concept, which is brainstorming your design plan and prototyping. And then, as I said, finally, once you have a prototype that works, you scale it up and you produce it. So just to motivate the idea of needs, here are the top 13 world health problems of the decade, according to the World Health Organization. And this was published pre-pandemic, but it's still very relatable. The first one is addressing climate crisis. Then we have delivering health amid conflict, fighting healthcare inequality, expanding access to medicines, stopping infectious diseases, preparing for epidemics, guarding against dangerous products, investing in health workers, protecting the world's youth, gaining public trust, harnessing new technologies, protecting life-saving medicines, and keeping healthcare clean. When I first read that, and I'm sure as you guys are hearing this, these are some huge problems, and there's not going to be a single solution to solving any of these, right? Like no one is going to be like, I'm going to solve the climate crisis with one solution. And so what we use this is really to guide a lot of the problems in addressing world health, but it doesn't really get to what a need per se is. So what is a need? First, especially when we're dealing with world health, it's really important to consider what the real underlying need of a problem is. Often when this isn't really considered, people fall into the trap of voluntourism, which is basically volunteering in a way that doesn't listen to the people being helped and actually ends up not providing any value to the community. And sometimes it even harms the community. It's kind of like being a savior and taking pictures instead of actually figuring out what the issues are. And so to avoid that, the biodesign method lays out 3 parts of the need statement. First is the problem. What is it that you are trying to solve? Is it a disease? Is it some conditions? Is it, water quality, et cetera? What is the problem that you're trying to solve? The second is the population. Who is the target market that you're trying to reach and help? Where are they located? What conditions do they live in? What do they have? What access to healthcare do they have? These are the kinds of things you have to think about when you're thinking about the population. And then when you put that together, it really comes down to what outcome you are trying to reach. If they use the technology, what will improve and what will change? And this is really the first big ideation step in innovation, is coming up with a list of needs statement. And it's in the form, a way to address a problem in a population that comes up with an outcome. And honestly, when people are designing and coming up with ideas, people come up with hundreds of these before filtering to the most important ones. It is important that these statements are specific, but also don't directly imply a solution. So you don't actually say how you're trying to solve the problems in the need statement, but rather keeping it broad enough such that you can have a ton of solutions for every need, and then that becomes the next ideation step. So what we're going to do is we're going to work on this together. Here are some example need statements. One is a way for students to interface with a physical representation of a neural network that maximizes learning. Another one is a way to provide long-term high-flow vascular access for hemodialysis with reduced risk of infection. Another one is a way to treat patients with continuous care needs that minimizes doctor-patient in-person interaction. And finally, a way to reduce physician burden and burnout by providing real-time feedback on stress levels. So notice how all of these simply list the problem, the population, and the outcome, but don't actually define how they'll be solved. So there can be lots of ideas for how they're solved in the future. So now I'm going to give you all some time. It doesn't have to be a healthcare application, but if there's a problem that you want to solve, what are some quick need statements that you can come up with? And type them in the chat on YouTube, and let's see what you guys come up with. Remember, it's a way to address a problem in a population that achieves an outcome. Oh, yeah, I can repeat. Basically, remember that it's a problem that, wait, let me read that again. It's a way to address a problem. Here, I'll put it on this slide. A way to address a problem in a population that results in an outcome. Cool. I've got a way to teach students about STEM without seeing each other in person. That's awesome. A way to give food to those who don't have food, which results in less world hunger.
A way to stop wars in a war-torn country, which results in less killing for everyone involved.
A way to give basic needs without much cost. A way to give money to those who are poor. A way to address food deserts in minorities, then make sure that they have healthy food. These are some really good ones. I love that you guys are thinking of all of these. And you know, just one thing is like make sure that they're specific, and then you start using these to come up with a way to get rid of taxes. Okay. These are some really good ones, and keep thinking about them because, as I said, this really kicks off. This really kicks off how innovation starts. Okay. So now, as you guys keep coming up with them, now we have a bunch of need statements, right? Needless to say, it'll be really hard to make all of them happen in a single solution. In fact, sometimes, as I said, when people come up with these need statements, they come up with hundreds of them. And so that brings up the question, how do we narrow these needs down? And so these are some of the factors that are used in the biodesign method. Slightly complicated, but also really important. The first one is disease state fundamentals. This is just a really fancy way of saying, what is the disease or the problem being faced and how does it work? Do we understand the research behind the problem that we're trying to solve? If it's a disease, do we know how the disease works? The question is actually really important, especially during the pandemic right now. For instance, in order to develop a vaccine, we need to know if any potential vaccines create immunity. We need to know what immunity looks like scientifically. So we need to know about how antibodies work. We need to know how masks actually prevent spread. And that all goes into the disease state fundamentals, and it's really important. Another one is existing solutions. So usually you're not the first person trying to address a problem. There's probably a ton of solutions that are out there, and understanding what they do and how they work is really important in defining how you specifically want to address your need. If there's something that's already solving one of your needs, you might not want to look in that direction, or you might want to improve on their solution. Another one, which kind of ties into everything, is stakeholder analysis. The stakeholders are all of the people that interact with or will be affected by a certain solution. I think this one, especially for world health issues, is one of the most important. In filtering down the needs, we really need to think about who the who is in the need statement. Who will use the solution? What do they need? Does this need match what they actually need? These are the questions that we need to be asking. And then next we have market analysis. This kind of ties up everything, but basically when we're looking at solutions, it's important to know how expensive the ones that exist are and how effective they are. That way, when we are developing, we can aim for the gap that hasn't already been addressed. And all of this basically means that research is required before jumping into development. And actually, this is a process that's really fulfilling. You find all of this out through interviewing the people that you want to help and asking them how you can help them, and listening to their issues and listening to what they need can be something that is really empowering, and also give you a really good idea of how to develop your solution. And so once you've done all of this research, then you come up with a set of criteria to filter down your needs. What are the must-haves in your solution? What are the nice-to-haves? And what don't you need? So here's an example of one that I made for a non-invasive blood pressure monitor kind of system. And notice how I have a list of must-have needs and a bunch of nice-to-have features. And that's how you really break down your needs, and you focus on the must-haves and then start adding in the nice-to-haves later. And it helps focus your ideation. Because in the next step, once you've had a few needs, you're starting to come up with all of the different ideas. And this is really the fun part of a lot of this innovation. This is the phase where we're brainstorming solutions and coming up with ideas, and we come up with another hundreds of ideas before we narrow down to a few prototypes that we want to stick with. The first step of this is pure brainstorming. And one of the ways that I really enjoyed brainstorming was when I'm with a team, and usually you're brainstorming with a whole team, you all come up with, you take sticky notes, you put whatever your idea is, and no idea is a bad idea. And you go and you put it on a whiteboard. And when you go to the whiteboard, you start all looking at it and you realize that there are patterns in a lot of your ideas, and you start clustering them and putting them together and drawing lines. And when you look at that entire pattern, you start to see actual solutions that you want to develop come up. And then that's when you get down to the building and the rapid prototyping. You start with design drawings if it's a really mechanical thing, or block diagrams to understand the system as a whole. Circuit diagrams for me, because I'm an electrical engineer, CADing, and then of course 3D printing. And just to show examples of all of that, here are some of the things that, again, like I had the chance to work on. Here's a design drawing of a non-invasive blood pressure monitor. Here's a circuit diagram for a water quality monitoring system. And here's a bunch of vital signs monitors that I had the chance to work on. And I'm going to talk about some of these as we get into the work that I've done later. But before I move on to things that I've gotten the chance to work on, one fun thing that I wanted to show is that how healthcare innovation is actually often tied to pop culture. I'm going to date myself a little, but I don't know how many of you guys know what this is. It's from Star Trek. A technology that I always found really cool was the tricorder. Dr. Beverly Crusher, she's like going to all the patients and all the people who get injured and trying to figure out exactly what's going wrong with them. And it's this whole sensor that they have for that. And what's really cool is I have technology like this in my house. There's telehealth devices that actually can tell a lot more about what a patient is doing on. And you can see how these two technologies are really similar and have similar ideation processes. The one down here, if you've watched Interstellar or any space movies, you see the astronauts going into these pods that they're supposed to go in really long time distances, basically cryopods, keeping them in a state of stasis. Actually, a lot of research is being done right now to keep people in stasis so that they can delay when their treatment is necessary. If you've seen Willy Wonka, I've always been fascinated because it's just a really cool lab. But the 3-course dinner chewing gum was one that I think is really interesting. And if you think about things like Soylent, which you're trying to give every meal in one now, maybe they got some inspiration from Willy Wonka. And then all you guys at Wizards, you might like this one. You remember this really gross potion that Harry had to have to regrow his bones, Skelegrow? That's kind of the basis behind tissue engineering. We're trying to figure out ways to regrow organs and regrow tissue, and it might make some really gross potion. So these are just some of the ideas I had. And I'm sure you guys have watched movies with a lot of other technical innovations. So what are some really cool ideas that you've had? Put that in the chat too. Back to tanks. I like that. Nice. Halo cryopods. A seed that can grow money on trees. Oh man. Teleportation. Yeah, these are all, hey, if teleportation was possible, it'd be so cool. Hover cars. Yeah, like technology in movies is really cool. If you've seen like Back to the Future and see how many things actually happen today, it's really fascinating. Cool. So now I'm going to transition. All of this has really been to give some context for a lot of the work that I've gotten the chance to work on, and should have given you a sense of how tech gets developed and ideated. So when I was in college, we had project teams. This is going to sound similar because robotics teams are basically project teams that you do before you get to college. But there were student-run organizations that worked every year to build some product. A lot of them were car, plane, robotics related. But for me, I was just really interested in joining one that was focused on med tech. So I joined our engineering world help team. EWH is a national org that inspires, educates, and empowers the biomedical engineering community to improve healthcare delivery in the developing world. They do a lot of really cool things, including providing easy to build kits for medical devices in developing communities and working on healthcare education. They also have a design competition that every chapter submits to every year of some World Health solution. And so this was our first idea. Our team was about a year old when I joined, and this was one of the first things we got to work on. And the need that we ended up addressing specifically was a way to monitor vital signs at remote clinics in order to reduce cost and provide more real-time feedback of patient vitals. And the way we actually got that was we sent a team to Peru and working in remote clinics there, and they found out that they really needed a way to communicate patient conditions to all the nurses really quickly and find a way to network everything together. State-of-the-art vital signs monitors cost between $2,000 and $10,000, and they tend to measure heart rate, blood ox, temperature, and those specific vitals. And what we wanted to do was create a prototype that costed less than $100 to build. And using Arduinos, Raspberry Pis, 3D printing, we did exactly that. But first, remember how I said there had to be lots of prototypes? This was our entire process. We came up with so many different solutions before coming up with our final one, and each one had its own improvement. In the end, we had a touch screen, we had LEDs describing the level of condition, so red was critical, green was good. There was also an antenna that had a way to send cell signals out, so SMS messages were sent based on the condition of patients. And in design thinking, initially we tried to build a pulse ox, and we realized that it costed way more to actually build it from scratch than to actually buy a solution for that. So these green things are actually our pulse ox that we bought just as a already built sensor. And so that kind of gives you an idea of some of the design thinking that has to go into building a product, and it did okay at competition. But what we wanted to really do after that was actually have an impact. And so for our next project, we involved a stakeholder. It was a nonprofit called Forefront. Forefront is a nonprofit that seeks to educate communities on sanitation, as well as build water wells with water filtration systems to expand clean water access across the world. For one of their water wells, they asked us to build a water quality monitoring system that would provide them, who are based in the US, water quality metrics live from a water well in Andhra Pradesh, India. This was something that we actually developed here at Cornell, and then we took it to India and implemented it there. And some of these images give how our design methodology works. So the one on the left was our first design drawing, and basically what we would do is plan. And so how our plan was, we were going to siphon water into a box. The box would be where the sensors were, and all these sensors are powered by a solar. Inside it was a GSM module to send these data updates to a web app. And the web app would measure things like turbidity, which is like the clarity of the water, pH, and other factors that measure water quality. And this kind of shows how we were building it. It was really cool that we got to implement it there, but this project did have its challenges and showed how important needs selection specifically was, and specifically also understanding stakeholder analysis. Understanding the needs of the community there was actually really important, and realizing that sometimes the nonprofits that we work with don't do that as much was a huge learning process. So the next year, probably the most fulfilling project that I got to work on was a neonatal jaundice phototherapy device. So if you don't know, jaundice is a disease often exhibited in infants that comes from elevated bilirubin levels in the liver. It is one of the leading causes of infant mortality across the world. What makes that especially sad is that the treatment for jaundice is incredibly simple. It's just shining blue light on a baby. Unfortunately, often phototherapy devices are big and aren't used properly. Sometimes they stuff several babies in them because they don't have the capacity. And then the other problem is in a lot of developing communities and even in rural areas in America, it's really hard to access hospitals. You have to go a really far distance. And this care requires the baby being there for an extended period of time. So after talking to doctors and after talking to people who work in remote clinics, we realized that we needed to make something that was really simple to use, but also something that could be taken home and that was portable. And that's how we came up with our need, a way to treat neonatal jaundice by any individual through a simpler, portable phototherapy device. One of the things that we did realize, though, is that, as you all know through robotics, collaboration is something that is really crucial. So through the process, my team came up with several factors that are here that need to be considered when we're developing an idea. And we had several design ideas called hamper, tent, and box. And what every member of the team did was rate, based on these criteria, how well each design would fit. And then we aggregated all of that data and realized that the hamper, which is like this doggy hamper foldable idea, was the one that made the most sense and was the most durable and fit all of these things. And so this kind of shows how we began designing it. We started with a CAD model showing how it would fold. Then we started actually building our prototype, embedding the LEDs, and then finally adding the netting to give a final product. And this one actually did really well at competition. We actually won like $5,000 for the idea, and it was really cool. So as we start talking about what I do now at MITRE, I know I've spent way too long on other things. I wanted to show you guys about a company that really has inspired me. It's called Design That Matters. It's a nonprofit that is focused on building medical devices and showing low-cost proofs of concept that can be expanded globally. what's actually at the center of their process is empathy and really finding a way to help these communities. And that was in particular really inspiring to me. And they have a really cool design methodology as well. So I will link this in YouTube later, but it's a TED Talk by their CEO, Tim Prostero. I highly recommend you guys check it out because if you're interested in really helping solve world health problems, he's a guy who has done a lot. And actually, that's where I got my idea for jaundice therapy. They have a really cool phototherapy device called Firefly, and that's what this is. And that's really that's what inspired that last project idea. So after I graduated, I started working at MITRE, where I've gotten the opportunity to apply all of those skills in the real world, and in frankly, really fun and exciting ways. So one of the first things that I got to work on was a project called Field Care. In the project, we developed a tool that provides real-time stress feedback for people in high-intensity medical environments. So think disaster zones, emergency rooms, areas of conflict, where medics can be really stressed out, really applicable today, obviously. In this project, we created an analytic that tells you how stressed out you are based on your vitals, specifically heart rate, breathing rate, and heart rate variability. And it tells you in red, yellow, and green how stressed out you are in a moment. But here's the fun part. We tested the analytic by playing paintball and having people who wear paintball wear these sensors so we can be like, oh, you're being shot at by a lot of paintballs. You've got to be really stressed out right now. The rules of the game were this. We had a team of doctors and a team of adversaries. In order to win, the doctors had to complete a set of challenges. While being shot at with paintballs, the medic in the team had to play several operation games, which already is a stressful enough game. Each time, take out a certain number of bones without it buzzing. Every time that it buzzed, they have to start their countdown over. So we really ramped up the stress on all of them. And that gets even more stressful by the fact that they're being shot at with paintballs at the same time. And the purpose of this game was really to validate the analytic and show that when people get more stressed out, that the analytic is giving feedback. And also so that we can learn that how to strategize based off of stress and getting this feedback. To really show how we validated it, here's an example of a particularly stressful situation.
I can't count.
So basically, she's being shot at by a paintball pro right over her head. And as you heard, she said, I can't count. Literally, with all of the stress, she couldn't hear, she couldn't think, and she couldn't process. And this entire stress moment, which I'll get to in a second. So this entire stressful moment is this really red spike here. It was really cool to see how just doing some math and doing some machine learning really quick came up with an actually working stress analytic. And we got to find that out through playing paintball. Just goes to show that engineering innovation can be done in a lot of ways, and you can be paid in the real world to go play on a paintball field. So why is playing paintball important, or stress analytics as a whole important? Well, not only is it useful in high intensity environments like that, it can be used in other applications. So for some context, physicians report some of the most burnout within their profession in the US. Actually, over 50% of physicians report burnout. And that number is increasing. Burnout is something that's characterized by exhaustion, cynicism, and general ineffectiveness at work. And really sadly, not only that, but the probability of physician suicide is significantly higher than any other profession. So we know that physician burn and burnout is a huge problem that can't be understated. To date, all of the studies that have been done have been qualitative to figure out why there is such a high burden and burnout and what is specifically causing that. But what this tool does is gives a quantitative way for studying that. So what you can do is during a day, by getting what their routine is, figure out where they have the most stress. Is it during their rounds? Is it during when they're actually meeting with patients? Or is it during things like electronic health record entry? And can we diagnose using this metric what's going on and hopefully provide some better recommendations for addressing this really important problem? So again, like take something from the paintball field and then apply it in a whole different area. And that's basically the crux of what so much engineering is. Another project that I'm working on is focused on detecting heart rate and respiratory rate from video. So did you know that when you take a webcam video, a computer can actually catch the blood flowing in and out of your face? When I found that out, I was really amazed because we really can't see that with our eyes. We can't just be like, oh, here's all the blood that's coming in and out, like with every heartbeat. So MIT actually had a really cool project called Eulerian video magnification that magnifies certain features of videos. So here's a video that's just straight up from a camera. Notice how not much changes. He's just staring really steadily into the camera. Now take a look at this one. That's actually his heartbeat. And just through magnifying these tiny features, you can actually get that. And so using those features, I basically get the heart rate, figuring out the rate that changes. And you can do a similar thing for respiratory rate. When you look around the mouth and see how we breathe, you can get the respiratory rate as well. So here's how that algorithm becomes really useful. The idea of remote and continuous care is becoming more and more important. We're trying to figure out how we can treat people without actually being in person and understand their conditions. When we think of infants, we want to be able to monitor their condition without actually sticking them with wearables and sensors on them. So what this can do is provide a way to have continuous care or screening of patients without actually having to put a sensor directly on them and doing that at a distance. One way to do this is to embed the system with a microcontroller, a camera, and a thermal camera, and then send the data off to a physician server that they can then use for analysis at any time. And to take a look at how that component would look like, you can have a microcontroller with machine learning capability, the visible camera to detect the face changes, and then actually the thermal camera detecting heat is the best way to detect your breath. You know, like every time we breathe out, it makes it really warm in our face. Of course, these are just the things that I've gotten the chance to work on. The world of medical devices is huge, and there are so many cool applications of engineering depending on what you're interested in. Since all of you guys are robo kids, did you know that robots are actually used in surgery? There are robots that happen, there are surgeries that happen where the robots actually do most of the surgery and the surgeon is just making sure that the robot is doing the right thing. Another cool one that I find awesome is deep brain stimulation. It's a non-drug way of treating conditions like Alzheimer's, Parkinson's, chronic pain, even deafness and blindness, basically by electrically charging neurons that are dead or aren't firing enough. Tissue engineering, remember I was talking about Skelligro, gives a way to print or regenerate tissue. I talked a bit about telehealth with my work. Prosthetic limbs are getting smarter and more natural. Actually, at APL, there's this really cool modular prosthetic limb. You take one of those myo sensors, which measures your electromyogram, so your electrical signals in your arm, which get down to your finger gestures and relays that down to the prosthetic. So the prosthetic still does what you're thinking that you want your hand to do. And it's really fascinating, really cool work. Another one is continuous glucose monitoring, especially for diabetic patients. It's a way to detect your blood sugar levels without having to continuously prick your finger. And also provides that continuous feedback of how your blood sugar levels are doing throughout the day instead of you having to continuously check that. So across all different kinds of engineering, there are applications in medical technologies, and they're really changing the future of healthcare, and it's really exciting stuff. And hopefully this got you guys motivated for that. And so with that, that's end of me talking for now. Any questions?
Thank you, Mr. Durvasula, for a wonderful presentation. And yeah, we do have a lot of questions from the audience. Let's start with the first one. Can we solve the COVID-19 pandemic by using the need statement?
I don't know if we can solve it by using the need statement, but I'm sure there are a lot of need statements that are out there. When we think about a lot of the different problems that the pandemic is causing, we start with things like testing. Um, a need statement is around there is like, how do we expand testing to as diverse of populations as possible? And how can that improve our understanding of the spread of COVID? And then, of course, there's vaccines. Clearly, there are need statements around vaccines and how can that improve the efficacy of immunity. There's the economic crises that are being caused by the pandemic. And so think about need statements along that. But what the importance of the need statement is, you take all of those really big problems, like testing is a problem or economic problems, and breaking that down into what the specific problems are, and then working on solutions that fix those specific problems and coming up with ideas that way. And need statements can be really helpful in that sense.
How does monitoring system deal with drought?
Can you repeat that?
How does the water monitoring system deal with drought?
Well, it doesn't. To be totally honest, you can't monitor water quality unless there's water, and that's a whole other issue. But I will say, you could probably look at things like the sedimentation and the quality of the water to predict whether drought is coming or that there is an overall lack of water. One of the things that we were measuring is flow rate. And obviously flow rate is going to go up when you have more water and it's going to go down when you have less. So these things are a way of understanding that drought is happening and alerts the people here that there are issues, or maybe there's even a clog in the system. And those are the things that need to be addressed with a water quality monitor. It can't really provide relief for drought. And I think a lot of that comes from the way the well was designed, which is not something that we were involved in. That's something that Forefront had to work on.
How does the blue light help with jaundice?
Oh, that's a really interesting question. So bilirubin, it's a protein that our liver generates. And what happens is in jaundice patients, it basically clumps together in ways that aren't good for health. And actually what ends up happening is you get yellow skin or yellow eyes, and it's a huge problem. What blue light does is when it's shined on the body, it actually is at a frequency that's high enough and it has enough energy to break down these proteins. You don't even need to reach UV to be able to do that for bilirubin as a protein, and which is why it's a really effective therapy for it.
How can you reduce stress if you're on a battlefield? Because the shooting all around you is already stressful enough. So how do you curb that?
That's a really good question. The nice thing about the way that we were studying this is that obviously they knew they were stressed when they were playing. You know, you're being shot at with paintballs. It's a really stressful situation. They weren't looking at the monitor being like, oh, I'm stressed. You know, you can feel it. But what they can do afterwards is, after a battle or after one of these situations, is look at that data, look at the moments that made them the most stressed out or caused the most anxiety, and then think about strategies of addressing those specific situations. What was one thing that was really cool, and I don't have a slide for this, unfortunately, is how the test evolved over multiple iterations. And every time we sent the folks in for individual studies, they came up with better strategies. In fact, that's why we had to have the paintball pro there in that trial, was because they got so good at it that they were winning every time. And there was basically no spike in stress. So we had to artificially create a more stressful situation. So basically getting feedback and understanding what situations were more stressful than other situations can help you strategize.
Can you check blood pressure with video recordings?
That's actually something that we're working on right now. you need a really clean signal to detect blood pressure because it requires some level of peak detection of the heartbeats. So unfortunately, when you're looking at a video, it is still really noisy. And so the way that I've primarily been looking at video extracted heart rate is just looking at the frequencies that the heart beats at, somewhere between 45 beats per minute and 240. So I'm not really looking at the signal per se, because it's really hard to see the individual signals. But there's techniques to stabilize the video and make the video better so that you can actually see the heartbeat. And when you can see the heartbeat and see the different components of the heartbeat, there are measurements that you can use using peak detection to actually calculate the blood pressure from that. It tends to be a relative blood pressure measurement, but if you have a good baseline, that's good enough. And so there are ways to do it, but they're being improved right
now. Could you use a video algorithm for looking at respiratory rate and heart rate for a lie detector?
That is a fair application. And probably, I mean, the only downside I want to say is lie detectors are often inaccurate and have a lot of false positives. In fact, a lot of the ways that they're used is really just to provide enough stress that people start telling the truth. So yes, you can use heart rate and these as stress measurements for that. But they'll get a lot of false positives. Sometimes you'll just realize that people are stressed. And we have to be really careful because it's used in a lot of places that are, for instance, in law enforcement, and we need to make sure that things like that are accurate.
A big part of surgery is touch. How can a robot have the same sense of touch and depth as a surgeon?
This is one of the ethical questions around robotic surgeries. They're really accurate, and the Da Vinci does have a surgeon operator there with really good cameras and gives a lot of really good vision. Obviously, if it is a surgery that requires touch, the surgeon is always there to provide that as necessary. There's no surgery that happens without someone being there and present as a fail-safe. So that's really important to know. But for the most part, the sensors in these do, for the surgeries that the surgical robots do, are really accurate.
Could you use the video algorithm for looking for respiratory rate and, oh wait, never mind, that's the same question, sorry. Are there any plans for measuring lung health as, for measuring lung health through?
Can you repeat that last part again? Sorry.
Are there any plans for measuring lung health in using the video monitor?
As of now, no. But obviously we have respiratory rate, and we're trying to figure out if using the vitals that we are measuring, can we detect things like COVID? Are there enough factors to detect that? Because that's really where a lot of that lung health question comes in. Respiratory rate is a vital that isn't used nearly enough, but it does tell a lot about our lung health. And you can use things like the thermal camera to see how people are breathing. But really the point of this is to be the first step before a doctor starts using a stethoscope and actually hearing what's going on inside.
So that was the last question we had from the audience. If you have any more questions regarding the presentation, please email them to us and we will forward them to Durvasula. ConnectCon will continue this afternoon at 2 p.m. with Dr. Eric Anderson presenting Adventures in Biomedical Science, What a Tiny Worm Can Teach Us About Ourselves. If you would like to be informed about more events and videos by our team, please subscribe to our YouTube channel, Wizards.exe 9794. Follow us on Twitter, Instagram, and Facebook, and check out our website. Thank you, Mr. Durvasula, for presenting at ConnectCon.
Thanks for having me.
Thank you, everyone, for attending the presentation today. Also, thank you to our alumni, Sarthak Bhatnagar, Angeline Zhang, and Ishan Oberoi for their help. See you this afternoon.